Okay, guys, Mrs. Ackland here. We're doing IXL volume of pyramids and cones, excuse me. So presumably we are going to have a mix of problems asking us to find volumes of pyramids and cones. How do we find those volumes? I don't know. Let's go find out. So let's go down here to these lessons and let's take some notes on the notepad. So volume of a pyramid. Okay, so let's look at what a pyramid is and then we'll write down our formula here. A pyramid is a three-dimensional shape with a base and three or more triangular faces that meet at a common point or a vertex. The base can be any polygon. So in this example right here, the base itself is a rectangle, but the base could be a triangle. The base could be a pentagon. The base could be anything at all. Okay, so the height of a pyramid is the perpendicular distance from the base to the vertex where the triangular faces meet. The height is sometimes called the altitude. And then there's also something called the slant height. Okay, so the height is this distance right here. And if you kind of can envision like a little triangle being drawn inside of this pyramid, the height is like the long leg, so to speak, or the vertical leg, and the slant height is like the hypotenuse of this little triangle. Okay, slant height is the height of one of the pyramid's triangular faces. To classify a pyramid, look at the shape of its base. For example, the pyramid above is a rectangular pyramid because it has a rectangular base. Here is our formula, okay? And it's written in a very general way because pyramids can all be different, right? So it's the volume equals 1/3 times the area of the base times the height. So let's add that to our notepad here. So this is volume of a pyramid, and it's 1/3 base. That when you have a capital B like that, it's not like a length of a base, it's an area. So area of the base times the height. And I'll put little stars in between those to indicate multiplication. All right, cool. So we know how to find the area, or sorry, the volume of a pyramid. Let's go down and let's look at the lesson for volume of a cone, because remember this lesson title says pyramids and cones. Okay, so what is a cone? A cone is a three-dimensional shape with a circular face and one vertex joined by a curved surface. So it seems like a pyramid and a cone are exactly the same thing. The only difference is the base of the cone is always going to be a circle, but the base of a pyramid is going to be some kind of a polygon that's not a circle. So it's going to be a rectangle or a triangle or something like that. Okay, and we have the same terminology that we had with the pyramid. So the vertex is this point up here. The height is this line right here. This distance sort of looks like one of the legs of this like triangle that's drawn inside of it. The slant height right here, the length of the side of the cone or the hypotenuse of said triangle. The radius of a cone is the distance from the center of the base out to the edge of the base. All right. And then this is the formula, 1/3 pi r squared h, which I'm going to argue is the same as the volume of a pyramid. So I'm going to say volume of a pyramid or a cone. Okay, because look at this, the pi r squared, that's just the area of the base, and that's what we have for our formula of a pyramid. We have that capital B. Capital B means the area of the base. Okay, so this general form is going to work for all of our problems in this lesson. If you're not sure what I mean by that, you'll see as we get into them. Okay, so 1/3 base times height. So we need to know the area of the base in order to put this into the calculator. We're going to need to know the area of the base, and we're going to need to know the height. Okay, so we've got a cone. It says, what is the volume of this cone? Use pi equal to 3.14 and round your answer to the nearest hundredth. Let's start with height because height is just going to be a number in the picture. The height here is the 10. Okay, it's that vertical distance from the vertex down to the base. Okay, and this base, because it's a circle and because it's a cone, because it's a cone, is a circle. So the area of the base is going to be the area of this circle right here. And we know the area of a circle is 3.14 times the radius squared. And right off the bat, they're giving us a tricky situation here where they're not giving us the radius, they're giving us the diameter. The whole distance across is 12, so the radius must be 6. Okay, so the base is going to be 3.14 times 6 squared. Let's go back to our formula again. So 1/3 times the area of the base times the height. Let's start to build this over here. All right, so 1/3, and that is going to stay the same for all of our problems. So maybe we'll just leave that 1/3 there for everything that we do and, erase the rest of it. The base was 3.14 times 6 squared. So 3.14 times 6 squared times the height, and the height is 10. All right, there's our answer. We're rounding to the nearest hundredth, which is 2 digits to the right of the decimal point. So there's no rounding needed. We don't even have 2 digits here. So our answer is going to be 376.8. Let's go ahead and submit. All right, another cone, and we know that our formula is 1/3 area of the base times the height. So let's go find the area of the base, and let's find the height. And I'm going to start with the height first because that's the easier one. The height is just the vertical distance from the vertex down to the center of the base. So it's going to be 9. This is a cone, so the base is a circle. So we're doing 3.14 times the radius squared. They did happen to give us the radius here. They did happen to give us 8 rather than giving us, the diameter and forcing us to divide by 2. So that'll be 3.14 times 8 squared. Let's go put this in. So remember, we're going to keep the 1/3 and we're going to erase the rest of this. Okay, so the base is 3.14 times 8 squared. 8 squared times the height, and the height is 9. Okay, so 602.88. Again, no rounding needed. We do not have any digits past the hundredths place. Okay, next up, it says, what is the volume of this rectangular pyramid? So the volume of a pyramid or a cone, regardless, is 1/3 the area of the base times the height. So let's put this up here. We need to know the area of the base, and we need to know the height. Let's start with that height. Height is just the vertical distance from the vertex down to the base, so it's just going to be 5. And then what's the area of the base? So this time, it's not a cone, it's a pyramid. And these bases can be really any shape. Okay, but not a circle. If it was a circle, it would be a cone. So this is a rectangle, or actually it looks like a rectangle, but really it's a square because look, the dimensions are the same. So how do we find the area of a rectangle or a square? We just multiply those 2 dimensions together. We multiply the length times the width. So it's going to be 3 times 3. That's it. All right, so we have the area of the base, we have the height. Let's pop back over here. We're only keeping the 1/3. That's the only thing that kind of stays the same from problem to problem. Remember, the formula is 1/3 area of the base times the height. Okay, so 1/3 times the area of the base is 3 times 3. And then the height is 5. So our answer is just 15. Definitely no rounding needed there. Okay, back to a cone. I know for all of these problems, we need to find the area of the base and we need to find the height. My height is 10. The base of a cone is a circle, so it's 3.14 times r squared. My radius is 9, and this is good. They didn't give us the diameter. They just gave us the radius. So that'll be 3.14 times 9 squared. Okay, back over here, delete everything but the 1/3 times. 1/3 times the area of the base times the height. Okay, area of the base, 3.14 times 9 squared. Times the height, which is 10. Okay, and I don't know if you guys are wondering this or not, but if you are, you might be noticing that when I work out the area of the base, and the height is usually just one number, but the area of the base in particular, I don't actually figure out what the base is. I just form the full expression, and then I put that expression into the calculator and kind of build the whole thing in the calculator. I do this so that my answer is as accurate as possible so that I don't get any rounding error. And also it just saves a little bit of time. Okay, here's our answer, 847.8. All right, back to a pyramid, but we know for all of these problems, we just need the area of the base, and we need the height. Height is 18. Okay, so this base is like a rectangle, or actually it looks like it's a square again, because it's 11 and 11. So it's just length times width. So it's just 11 times 11. Okay, back over here. 1/3 times the area of the base, 11 times 11, times the height, which is 18. There's our answer, 726. Okay, here's one that's a little bit different still. This is a triangular pyramid. But we still need to start with the same things. We need the area of the base, and we need the height. Height is 18, distance from the vertex to the base. Here's where things get a little different. This is a triangle, okay? So this is where we need to know all of those formulas of areas. I mean, we've already kind of seen this, but it's coming up more and more. The areas so that we can find volumes, right? So the area of a triangle is 1/2 base times height, and that's 1/2 little b times little h. So the little b is not the area of the base, but the length of the base of this triangle. 1/2 times these two dimensions, basically. Okay, so 1/2 times 10 times 13. That is the area of the base. Let's go pop that in. We still need the 1/3, okay, right? 1/3 times the area of the base. The area of the base also has a fraction, so we're going to have to be careful when putting this into the calculator. So it's 1/2 times 10 times 13. So 1/3 times 1/2 times 10 times 13. So this whole bit right here, 1/2 times 10 times 13, that's our capital B in our formula. That's the area of the base. And now we just need the height. Okay, so the height is 18, so we'll put a times 18 on the end, and our answer is 390. We'll do maybe this will probably be the last one. Actually, you know what? I don't even know if I have time to do this full one, but I'll get it set up for you guys. These videos can only be 15 minutes long. So for this one, our base, it's another triangle, so it's going to be 1/2 times these two dimensions. So 1/2 times 14 times 17. Okay, and our height is 15. It's a race against the clock. Can I do this? Let's go see. So 1/2 times 14 times 17 times the height of 15. Okay, so 1/3 times the area of the base, that's 1/2 times 14 times 17 times the height, which is 15. Answer is 595. All right, guys, good luck with this one. Let me know if you have any questions.